Well, welcome everyone. So this video is intended to accompany the ITS2300 lecture roughly in the second week, where we talk about IP addresses, specifically IPv4 addresses, and subnetting, CIDR, subnet masks, prefixes, those kinds of things. So I'm going to start this by doing a quick scroll through of the book chapter, highlight some things that make sense to read, some things that you might want to skip or skim. So let's get right to that. There we are. Nope, there we are. Let me get back to the top. So this is chapter 2 in the TCP/IP Illustrated book. It starts out so the the first section about IP addresses you definitely want to read. We talked about that. It has some nice breakdowns of kind of the binary notation along with the decimal for IPv4 addresses. Does the same thing for IPv6, which I'll never do on the blackboard. It takes too much writing, as you can see. So you get the comparison between the hexadecimal, especially in that first row, and the binary representation. Now, here's where it gets a little tricky in section 2.3. I mentioned this briefly in class. Skim over this classful addressing business, but understand that it's complete history. And this book is just old enough where it wasn't as much history when this was written. So the classful addressing has no role at all in the current network. So these class A, B, C, D, E addresses, not anything that is operational in the network now. So to skim over it, it really doesn't matter. It gets even more confusing when we get to section 232, because we now use the term subnetting in its more modern name, CIDR, somewhat interchangeably. That's unfortunate because in this book they correctly separate the two. So I think I'm going to say you can probably pretty much skip this altogether, right? So this figure here kind of is the problem, right? At one point, sort of in between the old classful addresses and where we are now, there were really sort of two separations in the address. One, it was the old class boundary, and then another boundary that the organization that had that class, an address out of that class, could choose on its own. It required some updates to operating systems, which this talks about. Just ignore this segment altogether. So what I'm going to suggest is you go down to 233 because it talks about subnet masks and prefixes that you do need to know, and so that's useful. The next section on variable length subnet masks is something we talked about in class. Yes, you definitely want to read that. Broadcast addresses we'll talk about in class. Skim over IPv6 because we'll loop back and focus on IPv6 in a future week in the semester. For now, we're going to focus on IPv4. So I think skim over that a bit. You already did you did some of the ifconfig, ipconfig stuff, so you can skip that as well. Now we get down to 2.4, the CIDR and aggregation. CIDR is classless interdomain routing. That's what we use subnet masks, or more precisely, what we use prefixes for today. Right, so this section is important. And he talks about prefixes correctly. talks about how they, they break down the address. And note he always does that for IPv6 as well, and that's fine. We just don't need a lot of the details of that yet. And talks about aggregation and why we actually do this. This is important to read, at least to sort of understand why we're, why we're all doing all of this. And then definitely read 2.5, because there's a bunch of addresses that are reserved for different purposes. And are not used as public IP addresses, so that is important to know. You can for now skip that for IPv6 though. Just focus on IPv4. Don't worry about the translators just yet. So 251, skip that altogether. We're gonna get back to that. Skim over the multicast stuff. You want to know what it is. We're not going to cover that in detail. So just kind of understand what he actually means by multicast. But in particular, once you get past sort of this table and what multicast addresses are, you can pretty much skip the rest of whatever this is, 253. We're not going to focus on that very much. In fact, you definitely don't want to be caught up in any of this stuff just yet. We'll talk a little bit more about that. Definitely skip IPv6 multicast. It's a big deal in IPv6. We'll get back to that later in the semester. Let's see if there's anything else in here. So 2.6 you definitely want to read because it talks about our method for ensuring that these global addresses actually will be unique. So definitely want to read 2.6. We'll get there very shortly in the lecture, in the class. So I'm kind of getting ahead a little bit here. Yep. So this section is important as far as addressing, although he gets into some fairly complicated addressing configurations here. So once you get past the first couple of sections in here, so single provider, single network, single address, you definitely want to understand that. After that, kind of take a look and see if you can sort of understand what changes when you have a more complicated organization. But it's going to take us a little bit of time to get there. So we'll probably come back to this at some point when once we talk a bit more about routing. You might want to just we're not going to specifically talk about a lot of security topics, but definitely read 2.8 and of course the summary. So that should at least give you a bit of a roadmap here. So roughly about half of this chapter or so is relevant, and some pieces that I pointed out more so than others. So make sure you kind of focus on those areas. Right. So then for the rest of this video, and I'm going to try to keep these relatively short. For the rest of this video, I'm just going to do one example of a subnet, of a prefix/subnet mask. Sort of see how that works. So let me jump over here, and so I'm going to pick an address that could be a machine here at OU. So address IPv4 is 132.235.67. Let's do 12. Now, so this address is globally unique. It consists of 32 bits. Bits 1 through 8 are in the first number. Bits 9 through 16 in the second. 17 through 24 are represented by the third number, and the fourth number is 25 to 32. This address is the unique identifier, but it doesn't allow us to find the machine unless we know what group it belongs to. And so let's say that our prefix for this is a let's make it a 29. Okay, so that says the first 29 bits are supposed to represent the group, and the remaining bits represent the individual addresses inside that group. And so 29 bits means it's all of the first 8, all of the second 8, all of the third 8. So that gets us to 24, and then we need 25 through 29 are still part of the group, and then bits 30, 31, and 32, the last 3 bits, are what we can make addresses out of. Okay. So what that forces us, so in order to make this work, we're going to have to take this very last number, which is split between the subnet number, the subnet identifier, and the address identifier bits. We're going to have to take this 12 and break it down into the 8 bits. And so that is 0, 0. Well, yeah, let's do it this way. I'm going to grab a different color. What do I have still? Okay, let's do this. 0, 0. So 12, I'm going to go from the other side. 12 is 0 1s, 0 2s, a 4, and 8. All right, so and again, I think I've mentioned this before. It's sometimes useful to write the values down. So you have 1, 2, 4, 8, 16, 32, 64, 128, 1, 2, 3, 4, 5, 6, 7, 8 bits. All right, so this the rightmost bit is worth 1. This is 2, 4, 8. 4 and 8 is 12. So everything else is 0. All right. Now what we just said was that we don't care about the bits 25 through 29. So 25, 26, 27, 28, 29. All of these are part of the subnet ID. So the subnet ID itself would then have the bits 0, 0, 0, 0, 1, 0, 0, 0. Right? First 5 bits have to be 0, 0, 0, 0, 1, and the last 3 bits are set to all 0. That's printed by convention, the subnet ID. And so we convert that back. So that is no 1, no 2, no 4. This is 8. So what that says is the subnet ID is 132.235.67.8. So this address up here, 132.235.67.12, belongs to the subnet ID 132.235.67.8/29. Technically, this is a valid address, but for historical reasons, it is usually not used. So it's only used to identify the subnet, the group itself. All right, so then let's finish up by figuring out what the last address is I can make. What is the biggest number I can make when I only have the last 3 bits available? All right, so for that, I will set those bits to zeros. I have to do the first 5, 0, 0, 0, 0, 1, and now I'm going to set the remaining 3 to all 1s. All right, because that's the biggest number I can make. When I do that, that's 1 plus 2 is 3, plus 4 is 7, plus 8 is 15. Okay, so the largest address would be 132.235.67.15/29. Now, that address actually is special. So this address, which is the highest one in this group, so all the addresses in this group are between 132.235.67.8 to 132.235.67.15. So 8 by convention won't be used. I could, and most operating systems will accept it, but most IT managers, most IT techs will not assign that. The other one I cannot assign. The last address in a group in a subnet is the local broadcast. So anything that's transmitted to that particular address is going to get picked up by every active computer that can see the packet. It's addressed to all computers in that group. So that was one example, and hopefully this helps. There are many resources for figuring out this sort of subnetting, including several of the Tech Nugget videos. So I encourage you to look those up as well, and obviously reach out to me if you have questions. So we'll wrap it up here, and I hope this was helpful for you.